The centralized electrical grid system that characterizes contemporary residential power delivery emerged through specific historical and regulatory developments during the early to mid-20th century. Prior to widespread grid electrification, household energy came from diverse sources determined by geographic location and individual capacity. Wood fuel, coal, kerosene, small-scale hydroelectric where water flow permitted, or isolated generator systems. The transition to grid dependency was neither inevitable nor universal in timeline, varying significantly by region and population density. The Public Utility Holding Company Act of 1935 and subsequent state-level regulatory frameworks established the legal structure for territorial monopolies. Utility companies received exclusive service rights within defined geographic areas in exchange for rate regulation and universal service obligations. This arrangement eliminated direct competition, a household within a utility service. Territory had no alternative provider option regardless of price, service quality, or preference for different generation methods. Physical infrastructure compounded this monopoly structure. Distribution lines, transformers, substations, and metering systems required substantial capital investment that only consolidated entities could finance at scale. As grid networks expanded, they created path dependency. Once a region was electrified through centralized infrastructure, alternative systems became economically disadvantageous for individual households due to the sunk cost already reflected in utility rates and property assessments. By the 1960s, this system had achieved near-universal residential penetration in developed areas. Household electrical generation largely disappeared except in remote locations where grid extension remained uneconomical. The cultural expectation shifted. Electricity became something purchased from utility companies rather than produced on-site. Analogous to how municipal water systems displaced household wells in urbanized areas. This structure differs fundamentally from other household resource categories. Food sourcing involves multiple competing retailers and direct producer relationships. Transportation includes personal vehicles, public transit, bicycles, and pedestrian options. Communication services operate through competing providers offering various technologies. Residential electricity in most jurisdictions remains a monopoly service with regulated pricing rather than market-determined costs. I'm James Sullivan. Let's examine how households navigate this monopolistic structure. The primary engagement method involves optimizing consumption within the monopoly framework. Households monitor usage patterns, shift high consumption activities to off-peak rate periods where time-of-use pricing exists, and pursue energy efficiency upgrades to reduce total kilowatt-hour consumption. This approach accepts grid dependency while attempting to minimize its cost impact through behavioral and technological modifications. Regulatory participation represents another pathway. Some households engage in Public Utility Commission rate hearings, advocate for alternative rate structures, or support policy changes allowing net metering or community solar programs. This engagement requires sustained attention to regulatory proceedings, understanding of utility economics, and coordination with advocacy organizations. The process operates on multi-year timelines with uncertain outcomes. Geographic relocation to jurisdictions with different regulatory structures or lower rates addresses the monopoly issue through exit rather than reform. Households research utility costs across potential relocation destinations, factoring electricity rates into housing decisions alongside employment, schools, and amenities. This approach trades one monopoly provider for another rather than eliminating dependency, though rate structures and regulatory environments vary significantly between jurisdictions. Supplemental generation within grid-connected frameworks has expanded where regulatory changes permit. Solar panel installations with net metering, small wind turbines where zoning allows, or battery storage systems operate alongside maintained grid connections. These systems reduce purchased electricity volume but retain grid dependency for backup power, nighttime consumption, or seasonal generation deficits. The household remains a utility customer with modified consumption patterns rather than achieving independence. Each approach operates within the constraint that the Legal and physical infrastructure of monopolistic grid delivery persists. Consumption optimization reduces costs, but not structural dependency. Regulatory engagement might modify rate structures, but rarely enables genuine competitive choice. Geographic relocation exchanges one monopoly for another. Supplemental generation reduces but does not eliminate grid connection requirements in most residential contexts. Consumption optimization encounters diminishing returns as efficiency improvements exhaust available reduction opportunities. Once LED lighting, energy-efficient appliances, and improved insulation are implemented, further consumption reduction requires behavioral constraints that degrade quality of life. Foregoing air conditioning during heat waves, limiting hot water use, or restricting appliance operation. The household is optimized within the system but remains subject to utility rate decisions and service reliability. Regulatory engagement faces structural asymmetry. Utility companies employ full-time rate analysts, legal teams, and regulatory specialists who participate in every proceeding. Individual households or even organized consumer groups typically engage episodically with limited technical and legal resources. The regulatory process favors institutional participants with sustained presence and expertise. Even successful advocacy often produces marginal rate modifications rather than structural alternatives to monopoly service. Geographic relocation addresses local rate disparities, but not systemic grid dependency. A household might move from a jurisdiction with 15 cents per kilowatt-hour rates to one charging 10 cents, reducing electricity costs by 1/3. However, both locations operate under regulated monopoly structures where the household has no provider choice, no rate negotiation capability, and no control over future rate increases or service reliability decisions. The structural relationship remains unchanged despite improved pricing. Supplemental generation through solar or wind systems continues to rely on grid infrastructure for critical functions. Net metering arrangements credit excess generation, but require utility cooperation and regulatory frameworks that can change through commission decisions. Battery storage systems sized for complete home backup during grid outages cost $15,000 to $40,000 and still depend on solar or wind. Generation that varies with weather. Most residential solar installations shut down during grid outages unless specifically designed and permitted for islanded operation. A household with functional panels on the roof loses power when their neighbors do unless substantial additional investment and configuration enables autonomous operation. The fundamental constraint is that all these approaches assume continuation of the monopolistic grid structure. They optimize, advocate, relocate, or supplement within a framework where genuine alternatives to utility-delivered electricity remain largely unavailable for typical residential contexts. Household-level electrical generation existed as standard practice prior to grid consolidation. Historical records document diverse generation approaches: small hydroelectric systems on properties with water flow, wind-powered generators, diesel or gasoline gensets, and various mechanical or electromagnetic devices. These systems operated before regulatory frameworks established grid monopolies as the sole legitimate household electricity source. Contemporary technologies enable similar household-level generation through updated implementations. Solar photovoltaic systems sized for consumption needs rather than grid export. Small-scale wind where geographic and regulatory conditions permit. Micro-hydroelectric installations. Electromagnetic generation devices operating on principles documented in historical patents, but implemented with modern materials and configurations. This format category is characterized by on-site generation rather than utility purchase. The household produces electricity through owned equipment rather than buying it as a service from a monopoly provider. Capital costs shift from ongoing utility payments to upfront equipment investment. Maintenance becomes household responsibility rather than utility obligation. The economic structure fundamentally differs from the purchase service model that grid dependency established. Regulatory frameworks vary significantly in how they accommodate household generation. Some jurisdictions require professional installation and inspection even for small-scale systems. Others allow owner installation within certain parameters. Grid disconnection faces different requirements than maintaining grid connection with supplemental generation. Electrical codes, building permits, and utility interconnection agreements create varying degrees of friction or facilitation for household-level systems. One format within this category involves compact electromagnetic generation devices using coil configurations documented in historical electrical engineering literature. These units typically consist of wound copper assemblies in specific geometric patterns, housed in enclosures comparable to portable generators but operating silently without fuel consumption. Implementation involves positioning the device in a utility area and connecting it to household electrical systems through standard wiring procedures. The devices operate continuously once installed, requiring no fuel delivery, engine maintenance, or operational intervention. Documentation distributed as assembly instructions and component specifications enables owner installation using materials from general electronic suppliers. The format exists outside conventional retail channels, distributed through technical documentation rather than as assembled products. This distribution model reflects the category's position outside mainstream grid supplementation markets dominated by solar and battery storage systems. This format represents one technical approach among multiple pathways to household electrical generation that preceded and now coexist with monopolistic grid systems. Its viability depends on regulatory environment, household technical capacity, available installation space, and individual tolerance for non-standard system configurations. The historical development of grid monopolies as the dominant residential electricity model was neither inevitable nor universal. Alternative structures existed previously and persist in limited context currently. The legal and physical infrastructure that established grid dependency emerged through specific historical processes rather than technical necessity. Monopolistic utility service continues as the standard residential electricity delivery model in most jurisdictions, supported by regulatory frameworks and infrastructure investments that favor centralized generation and distribution. Alternative formats exist at the margins of this system.